Hello, and welcome to EMC's video on the VNX virtual provisioning feature, which reduces the administrative cost of allocating storage for various applications. In this video, we will go over a few topics, starting with an introduction of the challenges associated with storage provisioning, then a feature overview of VNX virtual provisioning, then we'll go over a brief comparison between thin and thick provisioning, followed by the benefits of virtual provisioning. Then I'll show the concepts in virtual provisioning for file, and finally a demonstration of using the feature in Unisphere. There are many challenges that storage administrators face, and one of the biggest concerns is the balancing of storage requirements for various competing applications. Typically, administrators have to allocate storage based on anticipated storage growth, so applications have enough space in the future. Another challenge is when additional provisioning is needed, which incurs management expenses and may require application downtime. VNX virtual provisioning technology is designed to address all of those concerns by reducing administrative work. The technology allows disk drives to be grouped into pools, which form the basis for provisioning actions. Two types of provisioning that can be done are thin provisioning and thick provisioning, resulting in LUNs. Both types will be explained in the next section. In terms of LUNs, they are allocated space in 256 megabyte slices, allowing for better utilization of resources. Virtual provisioning technology also allows for advanced data services like FastVP, compression, and deduplication, which can be fully explained by searching in EMC online support. Thin and thick provisioning are both useful in certain ways, but the implementation of each is quite different. Thin LUNs have the ability to present more storage to an application than what is physically allocated. This means multiple LUNs can be created in a pool with a total allocated capacity greater than the pool, allowing for the flexibility of overscribing. As new writes come to a thin LUN, more physical space is allocated automatically in 256 megabyte slices, greatly improving utilization. For thick LUNs, the pool reserves the allocated amount of the LUN upon creation, ensuring the space will be available at all times. This means thick LUNs have a more predictable performance than thin LUNs. So if performance is more important than capacity savings, thick LUNs would be more useful. Let's move on to the benefits of virtual provisioning technology. One of the benefits is it reduces capital expenditure and ongoing costs by delivering storage capacity on actual demand using thin provisioning instead of on anticipated demand. This effectively reduces power and cooling costs by using fewer disks. Another benefit is the maximized utilization of storage assets. Again, by allocating based on demand, more value can be taken from the same resources and reprovisioning isn't a problem. The last benefit I'll highlight is the reduced cost of storage administration. There are many operations involved in setting up storage, including staff training, initial storage provisioning, adding new storage, and the monitoring of storage systems. Virtual provisioning simplifies all of those processes, allowing administrators to focus on other important tasks. VNX completes its unified approach to storage by offering virtual provisioning for file. The concepts mentioned earlier are similar, but not the same. For thick file systems, the storage is fully allocated, resulting in large amounts of unused space. Thin file systems are also fully allocated with an initial size, but has defined attributes to determine when it should be extended. Thin file systems also have a maximum size which is determined upon creation. The difference with the auto extend feature for thin file systems is there's no set extend amount like thin LUNs. It is based on a formula using polling interval, I/O rate, and high watermark values. Now we'll move on to a demonstration of using VNX virtual provisioning. After you log into Unisphere, you'll see this page. Now let's set up a storage pool by navigating to the Storage drop-down menu to Storage Pools. Click on Create for a new storage pool. In this window, you can see all the parameters that can be configured for a pool. If you have enough of the right drives, you will have different tiers of performance: Extreme Performance, Performance, and Capacity, which correspond to Flash SAS and Nearline SAS drives. This drop-down shows all of the RAID configurations you can use as long as you have enough drives. We'll leave everything as is and click OK. Now we can create some LUNs with virtual provisioning. To do this, right-click on the specified storage pool and click Create LUN. We'll allocate 100 gigabytes and keep it as thin. Please note that thin is checked as default when creating LUNs. Before we click Cancel to leave the window, let's create another LUN that's thick by unchecking the thin box. We can now click on the newly created thin LUN and click Properties. As you can see here, the user can see a capacity of 100 gigabytes, but the actual consumed capacity on the drives is only 1.753 gigabytes. Let's check the thick LUN for comparison. In the Properties page, we can see no consumed capacity as the entire LUN is already allocated for 100 gigabytes, which can't be used by any other LUNs. Let's now try setting up virtual provisioning for the file side. I already set up a thick LUN, connected it to the file storage group, and initiated a rescan of the storage systems to speed up the process. EMC recommends the use of thick, non-compressed LUNs when using thin provisioning for file. We'll now go to the File Systems menu by navigating to the Storage drop-down and clicking on File Systems. Click Create for a new file system. We'll name it FS1 for File System 1, set the initial capacity to 20 gigabytes, enable Auto Extend, enable Thin, and put in 100 gigabytes for our maximum capacity in megabytes. The high watermark is one of the factors in using the Auto Extend feature and defaults at 90%. Please note that you can enable Auto Extend without enabling Thin and provide a maximum capacity. But that maximum amount won't get reported to the host without Thin enabled. So the main advantage to thin file systems is the ability to report more capacity to the host than what is allocated. Now we can click OK and go to the Properties page. Here we can see the current allocated capacity and can change the high water mark and maximum capacity values whenever necessary. For additional resources on VNX virtual provisioning, please see the paper titled Virtual Provisioning for the New VNX Series Applied Technology on EMC Online Support.